projects. In this video, we are going to explain about a project titled Deep Radiomic Analysis for Predicting Coronavirus Disease 2019 in Computerized Tomography and X-ray Images. So now coming to the introduction part, in the swiftly changing realm of medical diagnostics, the incorporation of sophisticated computational techniques has become progressively essential. One standout method is deep radiomic analysis, representing a state-of-the-art approach poised to transform disease prediction, including the formidable task posed by coronavirus disease 2019 COVID-19. This pioneering technique utilizes advanced deep learning algorithms to discern intricate patterns and features from medical imaging data such as computerized tomography, CT, and X-ray images. This process offers advanced and comprehensive comprehension of the underlying pathology. So now coming to the objective part for this project is to improve the precision and effectiveness of diagnostic procedures. Conventional diagnostic approaches may occasionally miss subtle patterns and nuances that signal early-stage COVID-19 infections. Deep radiomic analysis employing sophisticated deep learning algorithms seeks to address these limitations by extracting detailed quantitative features from medical images. This aim is based on the necessity for a more nuanced comprehension of the disease manifestations in the respiratory system, where CT and X-ray imaging are crucial components. So now coming to the requirements part, here we have two types of requirements, the hardware requirements and the software requirements. In hardware requirements, operating systems as Windows is required. Processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda C is required and Visual Studio Community version is required. So now coming to the flow of work, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy and Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and C1 for visualization are important. The next here we have exploring the dataset. Here the dataset is examined to understand its structure, features and distribution. There are two subsets mentioned, one for COVID CXR images and another for COVID CD images. Third, here we have image processing. This section is divided into two parts. Using image data generator for transfer learning, TL for CXR. Rescaling the image, shear transformation, zooming the image, horizontal flip, and reshaping the image are all parts of the image data generator for transferring learning for the CXR. Then next here we have using Pillow and OpenCV for auto encoder, which includes a GMM, CNN, and PCA for CXR. Obtaining the images and assigning them to variables, reshaping and resizing the images. Then here fourth we have building the model. This section outlines the construction of various machine learning constructions or models for COVID-19 detection, including popular architectures like Inception v3, DarkNet, that is backbone of dense net 121, Exception mobile net, Ensemble model, Inception plus Exception, ResNet, PCA plus GMM CNN, and autoencoder GMM and CNN. Next we have training the model and dumping the model with exception. This step involves training the models with the dataset and saving the trained model specifically using exception with apparently provides better accuracy. Then we have importing the packages. It is similarly to the previous step which I have shown you about the NumPy and the Pandas Matplotlib library. Next we have exploring the dataset. Retrieving the exploration of the dataset, but this time for COVID CD images. Talking about the image processing. For CT, similar to the section 3, this involves pre-processing CT images for machine learning models. And then we have building the model. For CD, constructing machine learning models specifically for COVID CT images following a similar structure as we have discussed earlier. The next here we have training the model and dumping the model with mobile links which gives better accuracy. Similar to the section 5 we have discussed earlier, but this time using mobile net, which apparently yields better accuracy for CT images. 11th here we have Flask framework with SQLite for sign-up and sign-in. This section introduces the integration of a Flask framework with the SQLite database for user authentication, allowing the users to sign up and sign in. Then we have importing the packages. It is also similar to the previous one step. Next here we have user gives input as an image. Detailing the user interaction step, where the user provides an input image specifying whether it's a COVID CXR or CD image. The given input is pre-processed for prediction. This stage involves preparing the user input image for prediction by applying the necessary pre-processing steps. Then we have have trained models is used for prediction. The pre-processed image is fed into the trained machine learning model to make a prediction regarding COVID-19 risk. The last one here we have final outcome is displayed through front end. The result of the prediction is presented to the user through the front end, concluding the process. So now coming to the execution part. To execute the project, first we need to open the code folder. Here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Another folder named as static. This folder consists of files related to CSS, JavaScript and the Bootstrap file. And here .ipynb file, and this is the file which is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It then allows the user to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file which likely contains information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Next here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path from here. Open the anaconda prompt. Type the cd command followed by a space and paste the path over here and just hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. Here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste this link over here and now hit the enter button. Here you can see that this is our home page. About the city scan, CXR image, deep learning and the Flask framework. Now here you can see that there is a button for the sign up. By entering your username, your full name, email and mobile number and your password, you can do your registration over here. I have already done the registration, so I am clicking on sign in button. Enter the username and the password over here which you have created while doing the registration. So here you can see that it is showing an option for the choose files. Click on this option, choose any of the image from this, click on open button and now click on upload. So here you can see that the image which we have uploaded over here, it is predicting about the result. The given input image is the disease type is COVID. Depending upon the image you are providing over here, it will detect it. So let me choose the file once again from this folder. So now here you can see that I have chosen this image over here and now simply click on open button. Click on upload. So depending upon the image you are uploading over here, it will detect whether the cancer is there or not. It is showing that the disease type is non-COVID. Let's try with one more image over here. Click on choose file. And I am choosing this image. Click on open button and now click on upload button. Here you can see it is detecting again as disease type as non-COVID. So depending upon the image you are uploading over here, it will detect whether the disease type is COVID or not. Here you can see that there is the option for sign out button. By clicking on this button, you can simply log out with this. Let's click on the services button. Here we have two services, the CT and the CXR. So by clicking on the sign out button, you can simply log out with this. So now coming back to the conclusion part. In summary, the incorporation of deep Radiomic analysis and forecasting coronavirus disease 2019, COVID-19 using computerized tomography, that is CT, and X-ray images represents a groundbreaking advancement in diagnostic capability. Powered by advanced deep learning algorithms, this inventive methodology has proven its ability to notably improve the precision and effectiveness of COVID-19 diagnostics. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.